Hello everyone, welcome to Unit 3, Lesson 12, Noble Road. For this, by the end of the video, you should be able to answer the guiding question, how are noble gases useful in shortening electron configurations? Why can we use them? There is no do now for this one, because it is the second lesson for the class period. So it can be tedious to write out elements that have lots and lots and lots of electrons. So if we wanted to write out lead, and so we would have to look at lead, and lead is in the 6th row in the P block. So we would start at hydrogen. If we're going to do its full electron configuration, starting at hydrogen, it would be 1s2, 2s2, 2p6. You would end up with this, so make sure you write small. Well, sometimes it is a lot to write out all of that, right? Well, there is a shortcut. So the noble gas electron configuration, or noble gas shortcut, allows you to use the nearest noble gas, and that is the one right before it. So the one you just passed before you got to your target element, and you continue writing the electron configuration from there. So you start there and say, hey, from this reference point, this is the rest of the electron configuration. We only use noble gases, and a noble gas cannot be a shortcut for itself. Okay, so we'll get into that part in a little bit. So lead starts off as this. Okay, and so from this we can then switch it by or shorten it by using a noble gas electron configuration or core shortcut. So we look at lead and we go to the previous noble gas from it, not the one after, but the one right before. So that would be xenon. So if we look at xenon's electron configuration, it ends up being this. So this is xenon. So we can say xenon instead of all of that, and then continue from xenon. 6s2, 4f14, 5d10, 6p2. So instead of writing all of that, we can say from this noble gas spot, this is what the rest of it is. It is only noble gases that you can use as a shortcut. And when we continue looking, you cannot, and I'll come back to this one, you cannot use, if you are looking at a noble gas, you cannot use it as its own shortcut. So for instance, if we're talking about krypton, you cannot say, hey, it's just krypton. Nope. You have to use a different reference point. It cannot reference itself. So we go to the previous one, which would be argon, and we continue from there. 4s2, 3d10, 4p6. Okay, so this notation is super helpful in identifying the valence electrons as well, because they are the ones in the highest energy level. That means the N number is the biggest. Okay, so the N, if we remember, is the principal quantum number, which is this first number in front. So the highest one in the entire electron configuration, and there might be 2 or 3 or 4, but usually just 2. That highest, 1 or 2, that highest number is going to tell you how many electrons are, or like tell you which electrons are in the highest energy level. So if we look at lead, we see the 6 is the highest number out of all of them, because we know all of the ones for xenon are less than 6, and these two don't count. So that tells us that these are valence electrons. So the 6s2 and the 6p2 are the valence electrons, which tells us we have a total of 4 valence electrons for lead. And now on our periodic tables a little while back, we wrote some A numbers. So like 1A, 2A, 3A, 4A. And if we look up, we see that lead is in group 4A. That is a quick way for us to reference the valence electrons for every element in that group. Transition elements and lanthanides and actinides, or your inner transition elements, do not have a special way to denote these because their highest energy level is usually just the S block, and so that's 2. Looking at krypton, if we check, 4 is the highest number. So we add 2 and 6 for its total valence electrons, and that gives us 8. And we check, and it is in group 8A, so it does have the 8 valence electrons from our reference. And this is how we get those numbers. Okay. So when we look at lesson 12, Noble Road, you're going to use the noble gas shortcut to write some electron configurations. Please make sure you use your periodic table and that you check your work when you return to class. When you are finished, on page 13, make sure you answer the guiding question in 2 to 3 sentences. How are noble gases useful in shortening electron configurations? Why can we use them? There is no exit ticket if you were absent. And thank you for tuning in.